Hi again, this is Hadil, and you are watching the MIT Capstone Project's second part. I will show you in this part the database structure, and how the APIs have been built to work as a middle layer between the front end and the MongoDB. Our application relies on 4 primary tables within MongoDB to manage and store data. This NoSQL database is renowned for its scalability and flexibility, making it a fitting choice for our diverse data needs. Firstly, we have the user table. This is crucial for managing our user data, which includes fields like usernames, passwords, contact information, and refresh token. It forms the backbone of our user authentication and management system. Next up is the restaurant table, designed to store information about different restaurants. This includes details such as restaurant names, descriptions, emails for admins, passwords, and images. Our third table, the order table, captures all the order-related information. This includes order IDs, user IDs, restaurant ID, dish array, quantities, and payment status. Last but not least, we have the dishes table, where we keep track of all the delicious meals. This stores the dish names, descriptions, prices, and associated restaurant IDs. Together, these 4 tables allow our application to efficiently store, retrieve, and manipulate data, providing a robust structure for our backend. To begin interacting with MongoDB, we first need an instance of the database. During my development process, I utilized Docker to create a local MongoDB instance. Docker, with its inherent ease of use, ensures efficient management of software in packages known as containers. This is our docker compose.yml file, which is used to set up our MongoDB container. Once set up, we can connect to MongoDB using the default port 27017. After verifying that the local database connection was functioning correctly, I transitioned to an online MongoDB hosting platform. There are numerous services out there that offer free instances of MongoDB, providing scalability and accessibility. This approach allows us to move our database to the cloud, making it accessible from anywhere and facilitating collaboration among development teams. However, always remember to secure your database connection strings and never expose them publicly. To enable our Next.js application to connect to MongoDB, we'll use a powerful tool called Mongoose. Mongoose streamlines our database interactions, providing an easy way to implement CRUD, create, read, update, and delete operations. It achieves this by employing the concept of schemas. Mongoose essentially offers a straightforward, schema-based solution to model our application data. This includes built-in typecasting, validation, query building, and business logic hooks. Our first step is to install Mongoose. In our terminal, we simply run npm install mongoose. This installs Mongoose in our project and adds it to our package.json file. Next, we'll create a dedicated component for managing our MongoDB connection. This component will be callable from any other component that needs to interact with MongoDB. Creating an API to leverage our MongoDB connection is a vital aspect of our Next.js application. Fortunately, Next.js simplifies this process by providing a framework for building API endpoints. Each API endpoint in Next.js is essentially a handler function. This function is triggered when a client-side component makes a request to the API endpoint. Firstly, we import our connectDB function. Then we can call await connectDB within our handler function to establish a connection with MongoDB. After this, we can leverage the Mongoose model that we created earlier, for instance, user, to interact with our database. Here are some examples. To get data, we use user.find, which fetches all the user data from the MongoDB. To post data, we use newUser, reqbody, and then user, create, to create a new user and save it to our database. These examples illustrate how we can effectively use our connectDB function within our API endpoints to interact with MongoDB. And with that, we've successfully built our API to work with MongoDB in our Next.js application. Now I will talk about a powerful tool that helps to build the APIs. As developers, we often need tools that can make our work more efficient. One such invaluable tool is Swagger. Swagger is a powerful yet easy-to-use suite of API developer tools for teams and individuals, enabling development across the entire API lifecycle, from design and documentation to testing and deployment. With Swagger installed in our application, we gain access to a user-friendly interface for testing our APIs. This interface, called API Doc, presents an organized view of all our available API endpoints. As you can see here, all our APIs are neatly listed out. Let's test out one of them, the Get API for Restaurants. We hit the Try It Out button, then execute. The results section gives us the server response. Here, we can see the data returned from our MongoDB database, fetched by the Get/Restaurants endpoint. Swagger, with its dynamic interface, simplifies the process of testing and debugging our API endpoints, providing a boost to our development process. I hope this will be helpful information about the backend layer. In next part 1 we'll talk about the deployment and hosting the website. Thank you for watching.